Now we will see how we can connect any analog sensors or analog devices to the Arduino. That means it is not a digital. It will give the values in between 0 to 5 volt. For example, here I will show you. Yeah, here this is one LDR. LDR means it is a light dependent resistor. That means it will measures the intensity of light. Okay, it will measure the intensity of light. If the light is more, then it will pass the current through this. Okay, if I give the current plus 5 volt here, and here it is the another terminal, then if light is more, it will pass. If light is not there, then it will not pass. Okay, if the light falls on it, its conductivity increases. If that means the resistivity decreases, resistance decreases. If it is in a dark room, it offers a high resistance. Okay, so to measure the intensity of light now I have to measure the intensity of light using this Arduino and this LDR. So for that, now I will open the Arduino IDE and yeah, uh, Arduino. Okay, and here, yeah, it's opening. Oh no, wait, I will connect the charger. Yeah, I opened it, and here we'll go to new sketch and we'll close this older one. And here, okay, uh, yeah, here I will show this one. Okay, and here what I will write means in the white setup, I want something. I mean, I want to connect this LDR as the input. Okay, input. That means it has to measure the light intensity and it has to give those values to the Arduino. Okay, but here these are all the digital pins. Now we cannot use this digital pins. We can use these analog pins. Analog in. You can see this. It is written as analog in 0 to 5. A0 to A5 is that. This analog pin now we have to use. For that, what I will do means, first of all, same thing as digital pin mode. Analog pin, I will use this A1 pin. Okay, A1. Okay, I will use A1 pin. You can use any of those pins. I will use this A1 pin. Okay, a pin mode A1 comma input, input. Okay, remember this. If you write A as a small, then it will give the error. A should be capital, because you see here A are capital. A not A1, A2. Okay, this is my input. Now I have to display the data which is read by this LDR. So for that I am using the serial monitor. Serial dot begin, we will use baud rate 9600. This is as similar to the previous video. Okay, then here what I will do means, I will connect this LDR to the analog pin 1, because we defined this as the input. Okay, I will connect the analog pin 1. So now what I have to do means, I have to read the analog pin 1. So for analog read, because it is not digital, it will give analog value. It will give for the values from 0 to 1023. Remember this. This analog read, this function is there now. Analog read, it will read the values from these pins. That means it will read some voltages from these pins. The voltage ranges from 0 to 5 volt. Okay, in Arduino 0 to 5 volt. It will read the incoming voltage and it will gives us the value in the range of 0 to 1023. It will not give directly, it is giving 3.2 volt or 1.1 volt. It will give the values between 0 to 1023. So here analog read A1 analog read A1. Okay, but it reads the value. We need to store that value. So for that I will declare one variable int a. Okay, and here A equal to analog read A1. I will close this. Okay, now we need to display the light intensity. Okay, so serial dot print intensity of light is okay. I'm writing only print, not print ln, because I need this in a same line. Now I will write serial dot print ln. Okay, serial dot println. Println means after printing this, it will jumps to the next line. It will not print again in the in front if I write another serial dot print here, another line. So it's serial dot println A. That means I am displaying intensity of light is, what is the intensity that I am displaying in front of this. Okay, analog read A is the analog read A1. For every second I am reading the intensity, so delay 1000. If you run this code without delay, it will give very fast, all the results very fast. So I am using, it is not able to differentiate or see, so I will use the delay function here. Now let's see our code is proper or any error is there. Okay, it's compiling the sketch. Yeah, code is proper. Okay, now according to our code, we need to that means this Arduino will measures the intensity of light and it will display that in the serial monitor. So now for this hardware connection, what we have to do means, I think if you have the breadboard, you can use the breadboard, or else you can directly connect by using some wires directly to this, but that is not the systematic way. So for a systematic way, we are using this breadboard. So for that, what I will do means, yeah, I think now you can use visible this. Yeah, for that, what I will do means, here we see here from this analog 1 A1 pin, I am connecting a wire. You see from this I will for a time out. Yeah, here you see from this A1 pin I connected one wire. Okay, and that one I will connect here for some in the breadboard. Okay, then here is my LDR I will connect. Okay, LDR I will connect like this. Okay, see, LDR I will connect like this. Don't connect LDR like this because it will short, because all these are same pins. Connect like this LDR if you are using the breadboard, and this one I need to connect to the one end of the LDR, because the LDR will measure and it will give the output to this analog pin, and another pin I have to give on to the VCC. But according to some color codes or color things, we should not use this red color. Red color represents VCC always plus 5 volt. So what I will do means, from this side I will connect it to the VCC or plus 5 volt. Okay, there is no any plus or minus in this LDR. You can connect it to the any side. So here I connected, and one terminal I connected to the plus 5 volt, other terminal simply I connected into this hole. Okay, then from this hole I will connect this to the analog pin A1. That means now it will measure the light intensity. If light is more, it will conduct more. That means it will transfer this 5 volt to this analog pin completely. If light is less, that means if there is no light, then it will not transfer the voltage from here to here. If light is intermediate, it will transfer like 1 volt or 2 volt, like in intermediate voltage to the black wire, that means to the analog pin. So okay, you see this properly, it is like this. Yeah, okay, now what we will do means, we will upload this code and we will see. Okay, I am uploading the code, uploading. Yeah, then we will see in the serial monitor, it is giving intensity of light is 1023. That means full, because here full light is there. Now I will make this like I will close this. Yeah, now also it is giving 1023. Then what is the wrong? It seems it is right for the just to view this, it is all things right. Why it is not giving? See, it is sometime it will give you a 998 like that, it will just change 1998 1005. It is changing very less, but if I make complete dark, it has to give less value, no? For that, what is the mistake is there is no any error in the code, but here in this terminal, if any small voltage, that means if any small like that remaining voltage or remnant voltage is there, that also detected by the Arduino. No need to worry much about this. What I am telling is, if any small voltage is remaining here, that also will be considered by the Arduino. So what we have to do means, like you need to take one resistor like 100 ohms or 1 kilo ohms, one resistor. You need to connect not for the plus VCC, not for the plus 5 volt. Another side is there, no. For another side, you need to connect from this side, from here. That means after the LDR to the ground. Just connect it like this to the ground. Okay, that means you see now, this is my LDR1 terminal, and this is the plus 5 volt, this is the other terminal that I connected to the ground, and here I am connecting the A1 pin, analog 1 pin. Okay, that means it is a pull down register. If any excess voltage or excess is there, then it will pull down that to the ground. Now we will see. Now a code is already uploaded. We will see the serial monitor. Now you can see the light intensity is less when compared to, if you on the torch light, it will give the 1023. Now I will make close this. Yeah, now you can see it is reducing. If I close this much, you can see it is 883, 988. If we take this to the dark room, okay, then what I am doing means, if we take this to the dark room, it will not conduct. So for a time being, I will remove it. We have to get 0. Yeah, we are getting 0. That means it's working fine. Okay. Yeah, now you see, I will close this. Yeah, it is giving 973 in that range. If you want to look it in a good way, then you have to go to some dark room, then it will be visible properly. You can see, but it is in the range of 1023. So what I will do means, we need to convert this 1023 range to some 5 volt range. That means that time we can easily come to know how much intensity is there in terms of 5 volt range. So what I will do means here, before intensity, this A is now 0 to 1023, any value between that. I will do a small calculation here. It will calculating for 1023. I want for 5 volt. So what I will do means, A equal to this A value is equal to, no, you can yeah, this A value is equal to, no, it will confuse. Okay, I will declare other variable B. Now B is equal to A divided by 1023, A divided by 1023. Okay, A divided by 1023. That means for 1023 I am getting the A value. Then what is for 5? That means into 5, into 5. Okay, for 1023 I am getting some value, into 5 means that value in terms of for 5 how much I am getting, that one. Okay, it will do that conversion. Okay, then here I am printing the B value. Now we will see whether we will get in 5 volt range or not. I will upload this. Yeah, it's uploading. Yeah, it's done uploaded. We will see the serial monitor. See, now intensity is 0. why it's giving 0, because here it is in yeah, int. Instead of int I will use some float value. Okay, float means it is a floating point value, so that it will give accurate result. Float a comma b, a equal to analog read, and this is for 5 word, it is correct. For 1023 it is a, yeah, b. Okay, now I will upload this. You have to try. Okay, yeah, now you can see it is 4.98, 4.99. That means more light is there here. If I make the dark, this you can see, what I will do means I will remove this. Yeah, you can see 0000. Instead of these kinds of LDRs, you can use a slightly big LDR for more accuracy. That I will show you. uh, yeah, I have that, but it is not a proper one. It is some big LDR you can get in this shop. It will measure it accurately, so you can use this. We'll connect this. I'll make it full dark, means yeah, you can see I will full cover it. But what now, here my hand is something sweaty, so it is conducting here, so I'm not getting. I need to make it very dark. Let's use something like we'll close this. If you remove the register, you will see what it will give. It will always give something like 5555, and it is not the accurate value. You have to use a this pull down register, very like 100 ohms or 100 kilo ohms. Actually now I don't know what ohms it is, but simply I am putting. We'll do this. It has to give. We can conclude like if we go to night light, then it will give below 4.5. Okay, it will give, but here it is full of light. We'll see. Yeah, I found the reason why it is giving these kinds of values. That means it is not much more sensitive, because this resistance I use, no, this is a 100 ohms resistor. We should not use this. We have to use 10 kilo ohms resistor. I searched in just now which resistor is better, and pull down resistor, no. So we need to use something like a 10 kilo ohms resistor. That is the best one. So make sure that you are using 10 kilo ohms resistor. Don't use like very less resistance, very less resistance resistor. Use some like 10 kilo ohms resistor. That will correct this problem. But this is the actual way how we can measure the analog read. That means analog pins using the Arduino. We can you can try with some other stuffs like analog what we have to see. For analog sensors means some sensors, you look for some analog sensors and try with it. Sensors parts also I will explain, but LDR we can use like this, so that and one idea is that you can make something like during street lights, automatic street lights, by using this. If in the daytime it has to off automatically, and in the night time it has to on the LED. For that nothing is there, just here you have to I think you know how to make that. Just I am explaining that here. If my if yeah, this delay I will delete now. If my b value b, if b is greater than 3, that means if b is greater than 3 means b value it is greater than 3, so it is the daytime it will conduct full. So if b is greater than 3, then digital, right? your LED pin. That means for example, if I connect my LED to the pin number 13, 13 comma low, else means it is the night time, digital, right? 13 comma high. Okay, here I will declare that pin mode 13 comma output, because it is the LED pin. Okay, this is what you can do. If B is greater than 3, then it will makes the LED low. If it is less than 3, then it will makes the LED high. This is what how the street light will work. In this way, think about some ideas where we can implement this to solve some of the practical problems. Yeah, I hope you clear with these all those circuit connections. C1s, one resistor and one LDR, and two jumper wires are required. That's it. Thank you.